Hello everybody, welcome back to the channel. Been a while since I dropped a video. I was working on a project here in Galaxy Season, a couple of photos, and realized that multi-scale gradient correction, I don't see very many people using this in YouTube videos, instructions. I'm not seeing a ton of it in, I'll call it my mainstream YouTubers I'm following. I know there's plenty of people probably talking about it separately. Thought I would show how I use it for a galaxy and then one use of it on a hydrogen nebula photo. So the database files for multiscale gradient correction is part of the Mars project, and that database is growing in size, getting a lot more sky coverage, getting a lot more channel coverage. Right now, it's limited. You have to check if your target's going to be in the particular database, which I can show you what that means. And you're limited to only certain channels. So there's coverage for RGB and hydrogen in most cases. There's some oxygen coverage. I don't know about sulfur. I find that this is the best way to do gradient correction. If it's in a database, I recommend using it first. And if it's not, then go down the various options, whether it's ABE or DBE or Auto DBE from SETI Astro, which works really well on certain targets. I'll show you how I go about a couple different images here. Here we are in PixInsight. I am not going to show menus where to find everything. I think everybody's seen enough of that. Not going to explain how to install them either. I might mention a couple things around requirements as we go, but I really wanted to show, especially for galaxies for this round, easy way to use this. First example, the Needle Galaxy. I just shot this with my FLT 132, and we have a nice gradient here. On this particular one, you're thinking, okay, this would be great, easy target to hit. The first thing you have to do, flux calibration. I shot this with chroma filters, so you want to set your filters. This is an RGB image, obviously. So make sure you set your filters properly. And this one, I actually know the chip is on the list. So if the chip is not on the list, then you leave it on ideal curve, unless the chip's on the list. Now this has got a 571 chip, so I'm going to set it to the 571. I'm not doing narrowband. I did install the Gaia DR3 catalog and pointed it to this. Not going to explain how to do that, but if you have that installed, that's the one to use, the DR3, and everything else is default. So I go to run this. So here we are. The graph comes back. Fun to see graphs. Makes you feel important. Makes you feel scientific. But the reality is, kind of gotta just go with whatever you get here. The fact that it ran is the most important thing. So I finished the flux calibration, which is required for the multi-scale gradient correction. Now, I have the latest Mars files installed here. I don't really look and see if this is covered or not when I do this. And yes, it does cost me some time to try these things out. But what I do is just try to do the correction on the image itself. So these are all defaults. It's RGB. Get some previews, a preview set here. Usually, and then I run a test against the preview with the gradient model box on, and here we are. What we have was process console says error, no reference data found for filter R. So what that's telling us is the Mars database does not cover this part of the sky yet, so I can't use it on this image. Wow. I would use some other method. I'm gonna close this one out. So that's an example I can see when it won't work at all. The next example, take something really nasty. This data is from when I first started doing photography with my 81 years ago. And we have a huge vignette around it. I probably didn't have flats at the time. Didn't shoot no flats. And that's another advantage here, by the way, is we can mitigate all of these vignettes just with the multi-scale gradient correction. So same process. Open up flux calibration. I'm going to show you something else here. So I'm going to go to calibrate this. And it's like, I do not know how to calibrate. I do this because I don't have an astrometric solution. It is a requirement that these are plate or have an astrometric solution, and either this didn't have one or it got lost when I did some of the initial steps like cropping or rotating or whatever. I'm gonna run the image solver, and most of the time you can go by defaults. It does have the proper information embedded in here for 2021. That's definitely when I first started doing this. And we're going to run this plate solver, or I should say image solver. Okay, now it's finished. Now I'm going to run the spectrophotometric flux calibration. Now in this case, this is from my GT81. So we're going to go back to ideal curve. They're not chroma filters this time. These are ZWO filters. I bought the original combo of the 1600 Pro with the ZWO second version of the filters. They actually work fairly well. All right, so now I'm set up properly for this. Now we're going to do the calibration. This time around, we're not going to get the error, and we're done. And we got some nice, beautiful graphs again. Again, I feel very scientific when I do this. My scientific feelings go way up. Graphs always make me happy, even though I don't know how to read these. I did watch a video explaining it, but I've since forgotten what all that is, but you get the idea. All right, so now we have it calibrated. We're going to go for the gradient correction. Now, this is going to be interesting. Let me get this really crazy vignette. I got a fairly decent photo. I'm kind of impressed with myself, having just started photography with a telescope and went straight into fully automated. By the way, we're going to start by dragging off a preview and setting it to the same view. We're going to leave the show gradient model on. Everything is default. And this gradient scale is where we're going to start. So if we check the preview with the gradient scale, this will give you an idea without running it against the image. Is it really, what's it going to do? Okay, so this is definitely pulling what I want. So now I'm going to try to get more aggressive with this on the preview. And I'm watching the center here. I'm looking for the structure of the galaxy itself. All right, I see it starting to show up. So 512, we got that. I'm going to go the other direction, 1536. I'm going to take a peek at it. And okay, notice how much lighter the vignetting is of 1536. So I definitely want to go toward more aggressive to get that vignette out of there. When I say aggressive, you could pick different directions on this and calling it aggressive, less aggressive. For this particular image, it's more aggressive to drop the gradient scale. And other images, it can be more aggressive to increase the gradient scale, depending on that type of image. Okay, so I got a little bit of the structure showing here. The next thing I want to do is I'm going to play around with my structure separation. I'm going to check it different directions on this. Non-scientific. All right, that actually pulled down the structure from the center some, so it feels like one might be better. All right. Then lastly, I'm going to go down here, holding down control to move these simultaneously. I'm going to go off like a half of a point and check what it does. Okay, that definitely does not eliminate the structure getting pulled in the center, but maybe a little too aggressively. It's going black. I'm going to go back a little bit. Check it. All right, that's pretty close. Maybe 1.4. So this is a way you can make sure the structure, especially when we get to the hydrogen filter on a nebula photo, you'll see why the preview model is a good way to determine. You can also just run it against the photo over and over again, but it gives you a good idea before you go running it here. So now I'm going to come over here. I have all this set. I'm turning off the gradient model, and I'm going to run this against it. Like again, I could have done this against all against the main image instead of using a preview. I like to kind of play with the preview first, just to looking at the structures. There's still more vignetting, and the center's looking really good. I'm going to just, now that I'm here, I'm going to go a little further here. Oh, I should have undone that. That's the other nice thing about the preview, is you can keep applying and it resets the preview. versus here I'm actually applying it twice. So I'm going to back off, apply it once with the main vignetting we had, initial vignetting. All right, I am pretty dang happy with that. I'm going to pull off an image. Be a copy we can look at here in a second. All right, so then I want to reset this one more time. I want to go even further this time. Drag it off. Now I'm going to take this, and what we can do is hold down Control, drag this over to here. Before I do this, syncs their sizes. So as I zoom in and out, we can compare them. I'm going to toggle. Okay, the galaxy itself looks the same, except we got rid of more vignetting on the gradient scale, dropping to 192. I'm not going to go any farther because reality is I will crop this now. I will crop it about 90% of the image, or I might even crop it tighter if I want to make a close-up of this. Now here's the other part: is you can zoom in now, and when I toggle, it's already zoomed in on the other one, so you can compare things pretty easily with that being synchronized. All right, so we'll close the clone. We'll go back to this, which has got the better view. Close this out. At this point, like I said, I would go ahead and do like crop like that, and it's just going to kill the astrometric solution. Don't care about the preview, so I'm going to say yes. And now I have a very well gradient corrected image. All right, so that's one example of a very nasty, messed up flats. Okay, next example. Here's one that's got some rotated images in it. It's the luminance frame to go with that. So we're going to go in again to try to do a flux, see if it has a solution on it. Does not have a solution on it. You get the solver out, run the solver. Back in a second. In between edits here, I also went back and made a crop process so I can make these line up. Recrop the RGB. So we have this ready to go. I'm gonna do the hold on. So okay, in this case, ideal curve. Now this, you can just leave this UV-IR block out too. That works fine for ZWO, and then everything else is the same. Apply it. We got a connect curve done. This away. Go back to here. We're still set to L. Now this guy, I'm actually going to reset everything again. I want to drag a preview because I want to see if it does anything to the structure over here first. Run that. What we get? It's going to probably, yes, it's pulling out various parts. That actually looks really good right there. We'll go back over here and turn off the gradient model and run it. You can play around with that more. So now we're down to, it took out the gradient fairly well. I don't know. Go a little further with that. Go back to heavier on this. Undo it. Run it again. Okay, I actually like that better. So you got to play with this. You got to go each direction on gradient scales, then structures, separation, or scale factors. You can start with scale factor and come back to structure separation later. Your mileage will vary on these depending on the type of photograph you're working on. So I'm going to take this and apply the crop to it. And we got rid of all of our other nasty stuff around there. That would be my luminance for that image. So we got RGB luminance. Now, if I also did hydrogen highlights, in this case, we do the same thing. I'm going to go ahead and image solve this and flux calibrate it, and then we'll go straight to the multiscale gradient correction. So I am going to show something here. So this gray filter is going to change because we're going to go to narrow band. So in narrow band, we need the hydrogen alpha wavelength, which is up here. That's correct. And we need a bandwidth. This is a 7 nanometer filter, so I need to just set that for this, and then do the flux calibration. All right, so we got our graph. I feel more scientific all the time. So we're done with that. Another thing to think about, now your processing goes faster if you crop all these ahead of time, right? But you do not have to crop to do gradient correction with multiscale gradient correction method, because it's not dependent on using sample points within the image itself. Normally I would crop ahead of time though. So going in here, our gray filter now is going to be HA. And you, depending on availability of that channel being in the database, you may or may not be able to do oxygen as well. And I haven't even looked at the sulfur world. Going back to 1024 here. Can't even hardly tell if there's a gradient in here. I'm going to turn on the show gradient model so we can see it when it processes. You do that when you do the image itself. All right, so here's our model. Stretch it. So yes, there is a gradient. I see a tiny bit of structure in here, but not enough that I would probably normally care about this. But you could close this, undo it, shift, hold down control, shift this scale factor. So I'm going to go 1.2. I'm going to run it again. I'm looking at that structure. Might be hard to see it on YouTube. Pull it up here again. All right, that actually did not help. I'm going to go the other direction a little bit. Undo this. Run it one more time. Just checking. See what the best results are for the structure. That actually, I did like that. Okay, but I'm going to back it off a little bit because there's a tiny bit of structure in there. And close that out. Reset. Run it. Some of this can be time consuming, but if you want to squeeze out every little bit of quality in your images, things like this, it's going to make a difference over time. All right, this one or at 1, it's kind of debatable which one would be better. And I'm looking at the image. I like this. Like, obviously, as we get darkened up and stars extracted to get to the hydrogen portion of this to be utilized, but that's the starting point for it. And I would put my crop on there, and now I have a set of images for this RGB L H ready to go. All right, so the next one, example again, this would be if I were doing a SHO image and had my choice to do gradient correction and I could only use it on a few of the channels, I would still run gradient correction through this process and do others with a different process, because the hydrogen channel's got all the details. The most important channel is going to be in the Mars database most likely, and this is the one you have the risk of destroying structures with other methods, whereas gradient multiscale gradient correction used properly doesn't have that issue. So I'm going to image solve this, and I will show the flux calibration just because this is a different telescope setup. So when I started showing with the Needle Galaxy, so we're going to go into the hydrogen configuration with chroma filters, specifically the hydrogen alpha chroma filter. Image solving is done. Okay, and here we're going to pick the chip, the 571. We're going to stay on narrowband. We're using the 656.3. That's HA. Oh, and we got to change the bandwidth down. This is the 3 nanometer filter. I'll run it. All right, cool. I'm feeling even more scientific because I ran it against the chroma 3 nanometer. Close that out. Done with the flux. Bringing up multiscale. Again, still got HA set here. I'm going to hit reset just to make sure I don't have anything else out of whack here. Turn on the HA for that. I'm going to drag out a preview for this. I'm actually going to drag out more than one preview. Now I got to resize these, get them to the same view, just flipping between the tabs and hitting the zoom to optimal fit. So now, first preview, we'll use default settings, show gradient model. This will be more interesting than the others. So just running default without looking at the gradient models, whether you run it against the main image or you run it on a preview, not recommended. Here's why. Like if I just ran this default blindly, let's go do it. Go over here. The structure being pulled in. All this white is pulling in. It's pulling against the structure of the nebula itself. You do not want that. That's taking away signal from your image and not in a uniform way. So go back over here. I'm actually going to apply it to here without gradient model. And look how dark that is. It's like, see, that's how it's messing with it. Now, when you do that, if you did this, you would know right away, okay, that doesn't look right. But then you're like, okay, how am I going to tune it? Go back to this preview. We can start looking at the structure. Let's go higher on the structure. 1536. Usually the higher you go, more lenient this is going to be on hitting the core parts of these nebula. Oh, I didn't turn on the gradient. Ultra C on that. Let's look at the model. You can already tell that was not a good one. So now the structure is still less. We'll go even further. Go to another preview so you can see this separate look here. 2048. Drop another one on. Kind of want to get to the highest gradient scale you can get away with. So there's that. You can see how it's getting lighter. I'll go down here. I want to take this up to 3000. All right, I like that. And see how it's still got the actual gradient out here. It's not pulling really hard against the nebula itself. Now you can also play around with, like, this one's kind of close. You could use this one with adjusting the scale factors. We're going to test these things. It's going to go like 1.4 and rerun that. So the advantage of the preview is you don't have to reset it. You can just rerun it. All right, see how that pulled it down to that? And these two are very similar. I actually like this one better. So this is the 3072 with 1.4. We go back to this one. We can, well, before I do that, let's apply the 3072 1.4 I just did. All right, now we're getting a darkening of areas that we want darkened, but we're not impacting the core harshly. So I'm gonna pull an image over here of that, clone of that. I'm gonna undo this to the original. We're gonna hold down control and drag this over. That little orange dot said these are synced. Let me hide this. We're gonna overlay this image. Well, just toggle between them. So you can see how it balanced the lightness in the corners. But this corner in the bottom left actually has a lot of nebula, so it didn't really change it. What it did was it balanced the sky in the upper right, lightened the sky. But it also darkened some of these dark nebula areas around the structure itself. So we're going to zoom in. I want to show you something else. We look at the pillars themselves. You're going to see we got a little better definition off of that just by getting the gradients there. It's like an optical illusion. We're really talking about gradients, not deconvolution or anything. So, but I like how it turns out with that, the gradient, multiscale gradient correction. I might do some other videos on doing gradient correction using other tools in priority order. I mean, there's gradient correction, that PixInsight module gradient correction. That one just seems way more challenging to use. I need to spend some more time with it. That's probably going to be, your mileage is going to vary between that and all the other traditional tools. So I tend to find that very consistent and awesome results with multiscale gradient correction if my photo is in the database. So start there if you can, even though it might take a little bit of time to get used to it. Use the previews, use the various tools here, kind of go in order from gradient scale, and then your choice between structure separation or scale factors. Scale factors probably what you should get next. Structure separation may or may not have an impact depending on your photo. Just try out the different things. You'll get a feel for what works best depending on the type of photo. So that's a wrap for this video. Hope everybody learned something. Hope I inspired you to use a new tool. Maybe have a little consistent results coming out of your photos and for galaxy season. And for galaxies, you've got, you know, simple gradients a lot of times that don't really need a complex tool, but why not just have the real gradient of that sky applied to your photo without having to set data points and hoping you're not pulling structure out of your galaxies. So that's a wrap. Thanks everybody for watching, liking, and subscribing. Until next time.